Okay, we're in section 11 of the notes, and this is going to be the introduction to factoring. So we covered it. What do we cover? The type of factoring we're looking for, right? Now, someone says, what does factoring mean? It means taking something, like in this case, a polynomial, and writing it as a product, all right? And I'm going to be honest with you, that can be very, very difficult, but we want you to follow a procedure. And the procedure will be as follows. We talked about this again in lecture. The greatest common factor. Again, there's small videos on the side if you need to rewatch that. And of course, the full lecture will be published towards the end of the week. We talked about factoring by grouping, and I'll be honest with you, we write problems that really illustrate these points. You could certainly write problems where none of this stuff would work, but that's not our goal. Our goal is to reinforce what we're teaching by giving you examples that speak to these issues, which is GCF and groupings now. All right. When you see groupings at this level, when there's four terms. Next up is quadratics. Quadratics are probably the most interesting. My technique for quadratics, though, is going to be trial and error. A lot of students are frustrated by trial and error. They don't want to try. They want a surefire way of being able to factor things. And, I will be honest with you, the surefire way of factoring things, there is surefire ways, but they're so complicated. I don't think that's a good idea initially. You just want to try something. All right. What are we going to try? Simple things, finger numbers. And we're going to get there. All right. We'll get there. But I want to go through the procedure with you. And if we do that, it's going to be through the examples. Let me do that now. I'm going to do another share with you. And then we'll talk about one problem at a time through the share. And again, the problems are written to reflect what we believe, and that is we believe there's going to be a method to factoring simple problems anyway. I mean, more difficult problems, much more difficult to deal with. But if you're looking at this one over here, the first thing to say is factor it. And some students say, what do you mean by factoring? It means rewrite it as a product. All right. So someone said, how would you do that? Well, I go through my steps, and my steps are as follows. This is going to be equal some kind of product. The first thing I would look for is a GCF between the terms. And what are the terms? 5. And the other term is actually minus 20, but let's not worry about that. Let's put down 20x. But the term is minus 20x. What's the GCF between those? It's 5. That's the only factor they have in common. So what does that mean? Greatest common factor. They have 5 in common. Here comes the tough part for a lot of students. They say, what's there then? Well, 5 times what would give you 5? 1. Minus 5 times what would give you 20x? Well, that would be 4x. You check it. It's done. All right, let's go to number 2. And again, we're just simply saying, oh, they want me to write this as a product. Well, I'm still looking for the GCF. And the terms are going to be 2x squared. You don't need to write this down, by the way. The next term is actually minus 6x squared y squared, but I'm just going to put down 6x squared y squared because I'm not really concerned about the sign at this point. And that's a technicality, and don't worry about that technicality. What's the last term? 12xy. Now, granted, someone says, oh, it's too much for me to look at. Look at the number first. There's a factor involved. Now, between 2, 6, and 12, the greatest factor they have in common is actually 2. All right, we'll talk about that later. Now, if I look at the x's, there's x squared, and x. The greatest they have in common is just one simple factor of x. If I look at the y's, y squared, and y, well, they got a factor of y in common. So let's write that down. So the GCF is 2xy. Here comes the tough part. What's left over? Well, look at the first term. It's 2x squared y. Well, you don't need a 2. You already have a 2, but you need a factor of x. We'll check this later, by the way. Minus, well, I need a 3 because 2 times 3 is 6. And then I need an x because I need an x squared. I need a y because I need a y squared. Plus, well, what times 2 would give you 12 would be 6. And I got the x and a y. So I'm going to say this is correct. But you know what I want to do? It's a little complicated. I want to check it. How do I check it? Not by looking at the key, but by multiplying it out. You would get 2x squared y minus 6x squared y squared. I'm multiplying, by the way, plus 12xy Is that what we want it to be? Of course it is. It's 2x squared y minus 6x squared y squared plus 12xy. I'd also recommend looking at the answer key. 2xy, x minus 3xy, and 6. Looks like it's working out fine. All right, let's look at number 3. And again, there's 2 terms now. For a lot of students, that's a kind of a technicality, but there's actually 2 terms. That's one term, that's the other term. Do those 2 terms have factors in common? Well, let me talk about the factors of the first term. 4 is a factor, and x plus y is a factor. There's 2 factors. What's the factor of the second term? A and x plus y. Do they have a factor in common? And they do. And what is it? X plus y. Now, what remains though? From the first term, I need a 4. And from the second term, I need an A. I would recommend looking at the answer key to make sure you're staring at that. And if you're not, there's something horribly wrong. All right. Let's take a look at the next page. And I got to be honest with you, looking at this thing, someone says, what do you want me to do with this thing? It's really the same instruction over and over again. Factor, factor, factor. Well, I'm looking at this. And the first thing I notice is, and I'll put this down for you. I'm noticing there's 1, x squared is the first term, minus 5x is the next term, minus 2xy is the next term, and this is the fourth term. There's 4 terms. Of those 4 terms, they have nothing in common except the number 1, by the way. So what we try to do is we try to what we call a divide and conquer. And what we're going to do is, whoops, sorry about that. We're going to try to divide and conquer into 2 separate problems. So I'm going to put parentheses on the first one, which is going to be x squared minus 5x. I want to recommend, although not always the case, use the sign that's here to separate the terms. And this gets tricky for students. I know it does. And certainly if you need to take time to think about it, you should take time to think about it. But I want to write the minus down. And then if I write the second thing down, it's going to be 2xy and then minus 10y. Okay, before I go forward, I want to point out, you might say the principles are killing me, but it's still the same meaning. It's x squared minus 5x. You see it over there. Minus 2xy, I see that. And what's minus the minus 10y is plus 10y. So now what do I have? I have 2 terms now. Right, I put out the 2 terms are. This is a term. Whoops, sorry about that. Give me a second. This is 1 term, and this is 1 term. There's 2 terms now. So okay, you have 4 terms, I have 2 terms. What we want you to do is look at these terms separately and factor them. So if you look at the first term, which is x squared minus 5x, and someone says, could you factor that? Of course you can. There's a GCF there. What comes out? X, and we left off with x minus 5. Now let's look at the next term. Do they have something in common? Well, looking at 2 and 10, 2's in common, right? Now, they don't have an x in common, but do have a y in common. So what are you left off with? X minus 5. Okay, we still have 2 terms. This is the first term. This is the second term. However, these terms now have been factored. Do they have something in common? They do. They have the factor x minus 5 in common. So what I'm going to do is I'm going to pull it out. If you pulled it out, what would you get? X minus 5 times, well, the first term, to make it complete, I need an x. And the second term, I need minus 2y. And this might seem like it's magic to you, but I want to emphasize these are written to work. I still want to check it, not by looking at my keyboard, but multiplying it out. If you were to multiply this out, what would you get? X squared minus 2xy minus 5x plus 10y. Let's go through it. Look at the original problem. Do I see x squared? I do. Do I see 10y? I do. Now someone says I see these guys, but they're in different order. That doesn't matter. I still see minus 5x. I still see minus 2xy. Worked out beautifully. All right. Let's take a look at number 5. Number 5 is more realistic. And what I mean by that is the kind of problems I really want you to be able to factor. No GCFs, no factor by grouping. Why is that? At this level, factoring by grouping is only accomplished in 4 terms. Now, someone's going to say, oh, my teachers in another course would have written out a 4-term problem. I'm not opposed to that. But what I want to try to do is get you to try. So what I want to claim over here is, I bet this does factor. And the way I'm going to look at that, I'm going to look at this guy over here and this guy over here. Now, before I do anything, I want to claim to you, for me to get x squared, I know it comes from here. And what would give you x squared? Well, I'll be honest with you, there's an infinite number of choices, but I'm only looking for something easy. Well, that would be x and x, right? Whoops, sorry about that. By the way, I'm not saying it's working. I'm just saying that's the only reasonable choice I could come up with. Now, you'll get better over time, and I guarantee that. So I'm looking at 6. And I know it comes from over here now. Like something times something gives me 6. I got troubles though, and I want to tell you what the troubles are. It could be 2, and it could be 3, or it could be 6 and 1. And I just don't know. And this was called trial and error. Well, I'm going to try this 2 and 3 first, because I actually like smaller numbers. So I'm going to erase the second choice it could have been. And I'm going to stick with the 2 and 3 because I just like smaller numbers. All right, I'm going to put some signs down here. I'm going to see if it works. This is what's known as trial and error. Now, if you're completely clueless, try crazy things. You'll get better over time. And what does this give us? X squared plus 3x plus 2x plus 6. One thing nice about trial and error, I want to emphasize is trial and error is always giving us the first and last term. What I'm not so sure about is this over here. Do we get the middle term, which is 5x? And we do. Factorizations are unique. There is no other choice. However, you can commute it around if you like. It doesn't change it though. You could say x plus 3 times x plus 2. It's the same answer. Let's look at our k and see if we've got that. X plus 2, x plus 3. The order does not matter to us. All right, let's look at number 6. Same story. I'm looking at it, and I want to say what we're looking at initially. What we're looking at initially is just the first term and the last term. I'm not even looking at signs at this point. And again, in time, you might get faster at this. Well, to get to the first guy, right, comes from here. It's got to be x and x. If it's a simple world, I can't think of any other choice for that. If the world's really complicated, there's an infinite number of choices for it. And let me look at this guy over here, 35. And I could say, oh, maybe it's 35 and 1 or 7 and 5. I much prefer to go with smaller numbers, by the way. So I'm going to say 7 and 5. Now, someone says, where do you put them? Put them down. Where you put it down, that's entirely up to you. You got to start trying. Now what I have to worry about? I got to worry about all this nonsense in the middle. Whoops, sorry about that. A lot of nonsense there, isn't it? I got to get that. I'm going to try something, and maybe I'll get it wrong. If I get it wrong, I'll try again. I want to point out you probably should not try more than 3 times, because if you try more than 3 times, you're completely clueless about the technique. This will be my first try. What does try mean? You can't just write it down and say it's right. You have to see if it's right by multiplying it out. This is going to be x squared plus 5x minus 7x minus 35. Let's go through it one step at a time. Did you get the first term? Yes. Did you get the last term? Yes. What's my struggle? Did I get this? And what's supposed to be minus 2x? I did. I got it. So what do I now know? I know this is my answer. The answer could also be written down as x plus 5 times x minus 7. Both answers are identical. Multiplication or commutative. Let's look at our answer key. What does it say? X minus 7, x plus 5, x minus 7, x plus 5. It worked out beautifully. All right, let's go to the next one. I know it's difficult. I know a lot of students look at it and say, oh, my teacher in the prior course told me to rewrite this guy. I don't think it's a good idea. I think just take the problem as is. And again, what I'm going to do is focus in on what interests me, which is the first term and the last term. I'm not even looking at sign, by the way. We'll worry about this guy later. We'll worry about the middles later. So then the question comes is, how could you get 40? The problem with 40, and I want to be honest with you, 40 has tremendous choice. So for example, it could be 40 and 1. It could be 20 and 2. The problem with choice is it's really awful. I mean, when I mean awful, it's really awful. 10 and 4. You get the idea. I could be all day writing choices down. Not all day, but for a while, right? I guess I could do 8 and 5. You get the idea. And so what am I going to try? If you're completely clueless, all I can say is you got to try something. I would recommend, though, initially, stick with small numbers. That's what I'd recommend initially. So what do you think a good small combination of that? I'm going to say 8 and 5. I'm not saying it's right. I'm just saying if I'm going to go for a guess, I would say probably small numbers might be better for me. Here's the deal, though. By trying, you're going to get so much better at this just by trying. You'll see patterns. Like any game you play, you'll see patterns. Now, what do I like about the x squared? It's super simple. My problem now is I wonder, how could I get this thing to work? I got to try. And I'm looking at it. And I'm going to make a guess at it. So what's the guess going to be? Well, I know that 8 times 5 is 40. That's not a guess. I know x times x is x squared. But I want to focus in on, I need to get the minus sign over here. So I say, I got to put a plus minus somewhere here. All right. So let me try a guess. I'll put minus here, plus there. Let me just see if this works. What do you get? 8 times 5 is 40. Well, I got to be honest with trial and error. This is always going to be true. You get the first and last term every single time. It's the middle guy I worry about. And by practice, you'll get much better. I got the first term. I got the last term. Did I get the middle guy? No. 8x minus 5x is 3x. So don't give up. Try again. Let me erase this. Now, again, don't try the same thing twice. I'm going to move that around now, okay? Let's see if this works. Your second try, by the way. If it doesn't work, I have a third try. I'm not sure what I can try. If the third try, I don't know. Maybe I get totally lost. 8 times 5 is 40. Minus 8x plus 5x minus x squared. 40 minus 3x minus x squared. Did that work? Like a charm. This is a correct answer. There's only one possibility. Some people say, well, what if I wrote it in a different order? It's still considered the same possibility. All right, let's get our K. Let's see how we did. 8 plus x, 5 minus x. Good job. Let's go to the next one, which would be number 8 now. All right. And again, I'm looking at it. I'm wondering, can I do it? Here's the deal. We don't give you things you can't do. We only give you things you can do. It would be awful to give you things you can't do. So I'm going to give this a try. And I'm getting a little better at this. How could you get 39? You could do 39 and 1 or 13 and 3. I'm starting to think now. 13 and 3 seems very reasonable to me. I'm still going to try. This is x squared plus 13x plus 3x. You should never assume you're right, by the way, plus 39. Does it give us what it wants? It does. X squared, 16x, and 39. This is the correct answer. Again, the order in which you write that down could be different, but it's still considered the same answer. Let's look at our K, see if we got it. X plus 3, X plus 13, X plus 3, X plus 13. It worked out beautifully. All right, let's do number 9. I want to tell you, for a lot of students, what's the problem with number 9 is now we got this 3x squared. It's no longer just x squared. And I'm going to see if I can do it. All right, I want to see if I can do it. And what I like about trial and error is I can try. And that's what I like. I actually like the fact that I'm allowed to try, including if I get it wrong. All right, that's the only choice. In a reasonable order, that's the only choice for 3x squared. Now I got a 2 in the end, and the only choice for that is 2 and 1 or 1 and 2. So I'm going to make a guess at it. 2 and 1. I'm not saying it's right, but it's a guess. I can see plus signs everywhere, so I'll try this. This doesn't work, I'll try again. What do you get? 6x, I'm sorry, I made a mistake there. 3x squared plus 3x plus 2x plus 2. Well, I want to point out and try and error. I always get the first and last term, but did I get the middle term? No, that's 5x. That didn't work. So I got to say, I got to try again. So I'm going to cross this out. This is bad news. This didn't work. People get frustrated by trying no. I'll tell you why they get frustrated. I always say that the worst thing that's happened in your life is people won't let you try. Like you'll apply for a job and they'll say, no, you're not going to try that. I'm not going to let you try that. We want you to try. And the more you try, the better you're going to get this. Let's try again. Second try. I'll give up after 3 tries though. I'm just going to move the 2 and a 1 around like this. I'm not saying it's going to work. Let's give it a try. What do you get there? 3x squared plus 6x plus x plus 2. Well, the deal about this is you're always getting the first and last term. That's not my problem. Did I get the middle guy? Yes. So this is the correct answer. You could also write this down as x plus 2 times 3x plus 1. There's no other choice, by the way. So let's take a look at it. Did I get the 3x plus 1? Yes. Did I get the x plus 2? Yes. It worked out beautifully. All right. We are not trying to trick you, though. We're trying to get you to look for certain things. So let's take a look at number 10. Things are getting bad. All right. They're getting bad. They're getting bigger numbers. What happens when people see big numbers? They say, I can't do it. I can't do it. I can't do it. All we're going to ask you to do is try. Not more than 3 times, by the way. If someone says, why could you write that down so quickly? If it's a kind world, there's only one choice for 2y squared. And I got to be honest with you, you're in a very kind world. School is kind. They give you problems where you can do it. All right. Now look at the 52. 52 is a nightmare for me. And the reason why there's choice on it. So I'm going to write down 52. 52 could be 1 times 52. You could try it. I don't think it's reasonable. It's a big number, 52. I could say 1 times 52 is 52. That's not bad. I could say 2 times 26, right? You get the idea. At least I hope you get the idea what I'm doing. I can say 4 times 13. Boy, I got so much choice. Well, not really. It's only 3 choices I could try. Let me try 4 and 13 though. All right. Sometimes I'm going to say things you're not going to understand. That's fine. A lot of times in the conversation, people say things to you, you don't understand what they're saying. It happens. All right. You're not understanding. Here's the deal though. What I'm going to claim over here is that, and again, I hope you're listening. If I choose this over here, I want to tell you right now, 4 would not go here. Someone says, why do you know that? Because if I put a 4 here, there'd be a factor of 2 in common, and there was no factor of 2 common over here. So 13 must go here. I'll write that down for you. By the way, I'm not saying it works. All I'm saying is I couldn't have put it forward to 2. Now, where would the 4 have to go? Over here now. Here comes my trouble. My trouble is putting signs down. So I need to start looking at this. And I want to put out what I'm looking at. I'm looking at the middle term. I see minus 21. But I'm also seeing the product of 52. So I'm going to say probably, if this is to work, it would have to be this over here. Whoops, sorry about that. I want to tell you why I believe that's the case. I would never say it is until I try it though. A negative times a negative is a positive. But I would get an eternal sum that's negative. Let's see if this works. If it doesn't work, I'm going to try again. Let's take a look at this. What do you get? 2y squared minus 8y minus 13y plus, well, again, 13 times 4 is 52. That's not so bad. What does that give me? 2y squared minus 21y plus 52. Is that what we wanted? It sure is. This is the correct answer. And it's the only answer. Again, some students argue, oh, I could write it down differently. I could write down y minus 4 times 2y minus 13. That is not different. Multiplications are commutative. Let's look at our key though. What does it say? 2y minus 13, y minus 4. 2y minus 13, y minus 4. All right, let's look at number 11. Again, we're not trying to confuse you. What I'm going to claim over here is I'm looking at it, and this looks like trouble. And I'll tell you why it looks like trouble. The choices on number 1, which 21B would be too many choices for me, by the way. So what I'm going to claim over here, maybe we can make this a simpler problem by looking for a GCF. Now, someone says, I don't even remember you talking about the GCF. In the beginning, we said that's the first thing you should look for, a GCF. Is there a GCF? There is. It's B. What do you get? 21 plus 22B minus 8B squared. Let me check that for you. B times 21 is 21B. B times 22B is 22B squared. B times minus 8B squared is minus 8B cubed. By the way, that could be the answer. You factored it, right? However, I think there might be something else to do. And I'm going to claim over here, maybe I can't do it, but I'm willing to try. All right, let me put this down for you. Let's see, 21. It could be 21 and 1, or it could be 3 and 7. I tend to go for small numbers first, though. I'm going to say 3 and 7 might be. I'm not saying it's right. But I'm going to say maybe 3 times 7. That would give me 21, right? And then I'm going to look at that 8B squared on the end. I know it's negative, but I'm not too worried about that. I'm worried about the 8B squared. I'm going to say it could be, like 8B times 1B, 2B times 4B. Not much choice on it. I'm going to go with the 2B and 4B, and I'll write this down for you. So people get frustrated trying. I don't know why, though. I really would prefer to have a life of being able to try things. I like trying things, and I wish I could try more things in life, by the way. All right. Now I'm going to try this, see if it works out. Maybe I got it. This doesn't seem like it's going to be working, though, does it? Because if I want to do it, 3 times 7 is 21, and 2B times 4B is 8B squared. But no matter what I do with this, I would have like 12 and 14, and there's no way that's going to give me 22. So I want to erase this and say, I don't think that was very productive. And you're going to get better at this. Let me just talk about it again. 3 times 7 is 21. 3 times 2 is 6. 4 times 7 is 28. 6 and 28 do differ by 22, by the way. Let's try some signs. Who knows? Maybe we'll get it. Maybe we'll get it. Maybe we won't get it. So what's 3 times 7? 21, right? And 3 times 2B is 6B minus 28B minus 8B squared. Well, I get the first term and last term. Did I get the middle? No, that's minus 22B. That's a little upsetting, isn't it? I'm going to erase this then. I'm getting closer. I'm going to try something different. I'm going to try plus here and minus there. See if it works. But if it doesn't work, I'll give up. I hate to tell you that. 3 times 7 is 21 minus 6B plus 28B minus 8B squared. Does that work? Well, you certainly get the first term. You certainly get the last term. Did I get the middle term? I certainly did. That's 22B. So now I have my answer. Put a box on it. You can write this in a different order if you like. For example, you can write down as 7 minus 2B and 3 plus 4B. That's also fine. It's got to have those factors, by the way. So let's take a look at it, and one step at a time. Everything worked out fine. All right, that was number 11, and I think that covers it. All right, so what do you need to do? I would say go back over the notes. Make sure you understand what we're doing. We're trying to factoring, GCF, groupings, and then quadratic. You should also practice the homework. You need practice, by the way. A lot of students don't believe they need practice. You're just going to go backwards if you don't practice. What I mean by that, we get weaker over time. We don't want you. We want you to get stronger. We want you to move forward and thrive in your education. All right. So let's take a look. Go to the homework, do the homework, If you got questions, I'll publish those later in the week. I'll publish solutions later in the week. What I mean by that, me working at the whiteboard. You're also more than welcome to come by during office hours to get additional help if you need the additional help. Thanks for paying attention.